Let's look at this algebraic question involving a higher order degree polynomial and a higher degree Vieti's theorem. The general solution or the ordinary solution will be like we have fx equal to this, and we need to find g1. And g1, the gx will be a polynomial with leading coefficient 1, with 3 roots are reciprocals of the 3 roots. So we can say that basically what is g1 in terms of a, b, c, and so let's say g1 equals to x cubed plus a prime x squared plus b prime x plus c prime. So basically we need to find out the value of a prime, b prime, and c prime. So that will lead us to the Vieti theorem to third order polynomial. Basically we need to know the sum of the 3 roots of g1. And we know that the sum of 3 roots are actually 1 over x1, 1 over x2, 1 over x3, and which x1, x2, x3 are roots of fx. So the sum of x1 and 1 over x1, 1 over x2, and 1 over x3, we need to find out the common denominator x1 times x2 times x3. And the numerator will be x2, x3 plus x1 times x3 plus x1 times x2. So here are the pairwise product sum, and here the product of 3 roots. And luckily, we can use Vieti theorem in fx to find the value of those two. So the numerator will be b over, actually will be b over 1, right? If we use the Vieti theorem here, and the product of 3 roots will be negative c over 1. So the value of this is actually negative b over c. That's for x1, 1 over x1 plus 1 over 2 plus m over 3. And actually in g1, in gx, it will be equals to 1 over a prime over 1, negative. So this equals to negative b over c. So we know that actually a prime equals to b over c. Similarly, we can use the pairwise product sum to find out the b prime. So 1 over x1, x2 plus 1 over x2, x3 plus 1 over x3, x1 will actually equals to, let's find a common denominator similar to x1, x2, x3, and here just the sum of x1, x2, and x3. Also, we apply the Vieti's formula in fx, which will lead us to the sum of it will equals to negative b a, negative a. The product of it is still negative c. So that equals to a over c. And then if we apply the Vieti theorem in gx, that equals to b prime over 1. So just b prime. Similarly, let's find out the product of the 3. So it actually equals to 1 over x1 times x2 times x3. And just equals to apply the Vieti theorem in fx, that will lead us to 1 over negative c. Okay, and actually it equals to, when we apply the Vieti theorem in gx, that will equals to just c prime, negative c prime. Okay, so we find out c prime, b prime, and a prime in terms of a, b, c. So let's find the value of g1. It will just equals to 1 plus a prime plus b prime plus c prime actually equals to 1 plus, so a prime is b over c, b prime is a over c, and just 1 over c. So that actually equals to c over a plus b plus c plus 1. Okay, that's the solution 1. We need some calculation here, but it's easy to think about. Just if we're familiar with the Vieti theorem of third order polynomial, we can do this absolutely. But actually, we have a better way to do this, a much quicker way. So basically, if we assume x1, x2, x3 are roots of the polynomial of x cubed plus ax squared plus bx plus c equals is the roots of this one, then 1 over x1, 1 over x2, 1 over x3, actually they will satisfy something like, if we just divide by x cubed on both sides, that will lead us to 1 plus a over x plus b over x squared plus c over x cubed. Then actually we know that 1 over x1, 1 over x2, and 1 over x3, or just x1, x2, x3 will satisfy the equation of this, which tell us that actually if we have a equation that is cx cubed plus bx squared plus ax plus 1 equals to 0, then we will know that this x cubed, x squared, x, and 1 actually could equal to 1 over x1 cubed, 1 over x1 squared, 1 over x1, and 1. So basically, 1 over x is a root of a polynomial like this, same as 1 over x2, 1 over x3. So actually, this is just gx, but with the difference that the gx, the leading coefficient of gx is 1. Here is c, so we need to divide it by c. So actually, gx just equals to x cubed plus b over cx squared plus a over cx plus 1 over c. And that will give us g1 instantaneously.